This is a page showing some common lab equipment. You want to make sure when you're studying this, you know the names of the lab equipment. Some examples you want to make sure to study would be things like the flask, or things like the graduated cylinder. You also want to make sure you know what things like this do. What does the graduated cylinder measure? Does it measure mass or does it measure volume? You also want to make sure you know the lab safety rules. You should have a copy of the lab safety rules, but know that most of the lab safety rules are common sense. So when you look at this, you could see that you should always wear your goggles. You should wash your hands after working with dangerous equipment, and know what the right things are to wear in the lab. Something that this doesn't show that is important is you should tie back any long hair, and that you should always listen to your teacher's instructions before you do any unauthorized experiments. When you're studying mass and volume, first you want to know how you can measure mass and volume. So we can look at the tools. Volume, we see, is measured by a graduated cylinder. And why do we want to know that? Because volume is measuring the amount of space an object occupies. Mass is measuring the amount of matter in an object. We use a balance to measure the amount of mass. In our class, we don't have a triple beam balance, we have an electric balance, but both measure the same thing, the amount of matter. Density is telling us the relationship between mass and volume. Density is a property that something has. We measured the density of solids and liquids in our class. Something that you might be tested on is the density of a solid. So what you would do is you would take the mass of the solid divided by the volume of the solid. So if we had something like the mass was 12 grams and the volume was 4 milliliters, the density would be 3 grams per milliliter. Another question you might have is copper a large piece of copper the same density as a small piece of copper? The answer would be yes, because they are both made of copper. Look at this amazing periodic table. It is color-coded and very exciting. So, let's talk about it. First of all, we've got some very exciting stuff to talk about. I'm sure you remember this. When we look down at the periodic table, vertically, it's arranged into groups, and going horizontally from side to side, they are called periods. Okay? Groups are things that vertically have things in common, and we need to know the names of some of our groups. The first group is called the alkali metals. The second group are called alkaline metals. And all these guys are actually metals until you get over here. And then we've got nonmetals. This beige group are called halogens. And this gray group are called noble gases. And noble gases are very important to us because they are unreactive. And the reason why is because their electron shell is full. Something important to know about the alkali metals is that as we go down, they become more reactive until we get, they become so much more reactive as you go down the periodic table, they will actually explode when contacted with water. The periodic table is organized this way because there are trends within groups. For example, when you go across, you can see it starts with 1, 2, 3, 4. Like it goes up by atomic number, And then similarly, within groups, they have things in common, so that's why it's named that way. There are trends with reactivity and things like that. So those are some things that you need to know, as well as the names that I wrote on that. Okay, the end of this slide. Let's go on and learn more. This is one element. What you need to know is how to calculate protons, neutrons, and electrons. It already points out the atomic number. So to figure out protons, that is the atomic number. That tells us protons. It also tells us the electrons. Okay, in an atom. Okay, to figure out the neutrons, what we're going to do is take the weight rounded to the nearest whole number, which is going to be 84, minus the atomic number, and that is going to tell us the neutrons. If I could spell, this would be helpful. Neutrons equals mass minus protons. Okay, so 84 minus 36. Okay, we've got to do a little fun subtraction. So 14 minus 6 is 8. 7 minus 3 is 48. So protons is 36. Electrons equals 36. Neutrons equals 48. And see, I just wrote that with a pen, so that is how we also write that, P-E-N. An isotope is when an element has different numbers of neutrons but the same protons and electrons. Okay, so what you're going to notice is the mass is different. And then the way that it's written is with a different mass number. Okay, so in oxygen 16, it has the mass of 16 minus the number of protons, which is 8, equals 8 neutrons. Oxygen 18 has a mass of 18 minus 8 for protons equals 10 neutrons. Protons stay the same because it's still oxygen. The thing that differs in an isotope is the number of neutrons. Okay, here's our last topic. We need to learn about nuclear reactions. Nuclear reactions are the only thing that can change the nucleus. So there are two types. The first type is, that's exciting, the first type is alpha decay. Alpha decay is when a helium nucleus is ejected. So here's our first example. We start out with something that has 94 protons and a mass of 240. So we want to see what the overall reaction is going to be. So here is what we are starting with. It is right here. Okay, so it's Pu. It's got originally 94 protons and a mass of 240. So we want to see Y is our final uranium 92. So if I eject an alpha particle, I'm ejecting something with 2 protons and a mass of 4. So I eject something with 2 protons, okay, so that's why I'm going back to uranium, and something with a mass of 4, so that's why my final mass is 236. You guys are just going to be taking a multiple choice test, so when you figure this out, 240 minus 4 is 236, 94 minus 2 is 92. You want to make sure that your math adds up. The other one is beta decay. This happens when there's too many neutrons, and there's going to be a neutron that changes to a proton, and then the extra electron is going to eject out. So the way this works is your mass stays the same because neutron changes to a proton, and the electron's got to get out of there. So here I've got lithium, okay, number 3, mass of 8. So if a neutron changes to a proton, that means it gets bigger, and then my mass stays the same. So my mass is 8, and then number 3 goes to number 4. Electrons don't have any mass, so that's why my mass stays the same. So here is my atomic number on the bottom, and then my mass is on the top. So that might be a little bit confusing. So here's Li 83, that is my mass number, and this is my atomic number for reference of how these equations are written. So you just want to make sure when you are seeing these that the final mass on this side of the equation, when you add those two numbers together, that they match what you started out with. So you have 8 on both sides, and you have 3 on both sides, because 4 and -1 balances out to 3. Same with this one, you have 240, 236, and 4 adds up to 240. You had 94, 92, and 2 adds up to 94. The last thing you have to know how to do is some formula writing. You have to be able to balance if you see some ions. So if I have something like Na plus and Cl minus, they are both charge of 1, so it's going to be NaCl. But what if I had Na plus and O2 minus? Okay, then it's not balanced. I need to have 2 Nas, so my charge is plus 2 and minus 2. If I have something polyatomic, which means I have more than one, something like calcium and here's a polyatomic ion. I'm thinking of this because it's the winter. I keep my carbonate together. If it was something like this, when I have now, this is a plus 1, this is a minus 2. I need 2 potassiums, and it becomes K2CO3. I need 2 potassiums and 1 carbonate. So my pluses always have to balance out my minuses. This is one example.